Okay. So hi everyone, nice to see you here again. Today we're going to talk about React in depth. We're going to talk about more complex things in React, how to deal with them, how they're helpful for us, and how you can apply them to your application. And additionally, in the end of the lecture, we're going to discuss your home task a bit, so you have time and option to ask questions if something isn't clear and stuff like that. So let's begin. And the first topic we're going to talk about is prop types. So as you already know, in order to pass data from the parent to the child, we use props in React. And in order to add typing to this thing to be certain that we are passing the data that we expect to be passed and stuff like that, we can use library prop types. It allows us to check types of types of props in your application. It can help with finding issues. For example, if you pass number or but this component was expected to have a string, it will highlight you that something isn't right. It checks JS type, React elements, many items, required props, and so on. That's nice things about prop types. And unfortunately, prop types won't help you in production mode. It's only for development stage of your building your application. And there are a few more libraries that can provide more features than prop types, though prop types in most of the cases for a small applications will be more than enough. So for example, if you're gonna wanna go on a step further, you can use Flow or TypeScript. That's completely fine. If you just wanna to add typing to your props, prop types is your way to go. So install it as a regular library to your application through the npm install and stuff like that. So that's how your typing would look like. So for example, this is your component, the file of your component. So after you described your component, something like that, you add this block. So you add a property to your component prop types that equal an object that describes types of your props that are expected. So optional array, optional bool, stuff like that. Obviously, names would be different. Just for the sake of an example, here how we're gonna define type of certain property, and next time if we, for example, add some property to this component and we won't add typing here, yes lint or console would tell us that, hey, you didn't add typing for this prop, for example, and in future when we try to pass something that isn't right in scope of the typing, for example, like here, this is how prop types will tell us in def mode that something isn't right with property that you're passing. So here you can see that it will tell you that this is a warning, valid prop type, invalid prop name of type number, it's applied to hello's name of component, expected string. So here in an example, I passed number instead of string. This is how prop type will tell you. And something isn't right here. As you can see, component hello have some simple rendering, and in the end of the component, I added typing for my property name as a string. Yeah, these prop types can come from React, or you can get it, the prop types object, you can get it directly from a library. So import prop types from prop types in small letters. Stuff like that. So prop types also allow you to do much more than that. You can describe more complex structures than just array. You can define different structure of an object. You can add is required if you need this property to be passed in order to render your component, and stuff like that. So definitely very helpful library, and I'm encouraging you to use it in your application. Yeah, so when we've been talking about React components and about class components in particular, I mentioned that class components have lifecycle methods, and functional components don't have them. And now we're gonna go in depth. What is that? What does it mean, the lifecycle method? So there are basically three stages or phases of the life cycle of the component: when it appears on the page, when it's mounting, when you update data in this component state or props, and when you remove this component from the page, and it's called unmounting. There are few lifecycle methods. So this is stages. Every stage have a few methods, lifecycle methods in it, and render is the only method that is required to be in the component. So render is also a lifecycle method. It take place in mounting and in updating. Yep. So the component's lifecycle have the different phases. Yeah, we talked about it. So yep, let's go further. So this is a simplified structure for lifecycle methods. So first of all, we have let's say three stages: mounting, updating, unmounting, and in all of these three stages, we have different phases. So render phase and commit phase. In render phase, we don't have side effects, so we don't do any requests. We don't don't mutate any data outside of the component and stuff like that. This stage can be paused, aborted, or restarted by React. So this phase have constructor. So if you remember, I told you that in current React version, we don't have to have constructor anymore, but anyway, it's there. We don't need it just because of year 6, and it's syntax sugar, but it's there. It's in the mounting in render phase. Then we have render itself. As you can see, as I told you, it takes place in mounting and updating. Then we go to commit phase in mounting, and we end mounting stage of the lifecycle of the component with component did mount. So this lifecycle methods will be called when mounting of the component ended. And as you can see, it's in commit phase, so we can do any side effect that we wanted to do. For example, requesting. We can start working with DOM directly if we need it. You might ask me how we can do that, but we'll talk about this a bit later. Obviously, usually in React, we don't work with DOM directly, but there are a few cases, and we'll discuss them a bit later. We can write side effects here and schedule updates here. So, yep. All these lifecycle methods that I will be talking to you can be added to the component as well as we do with render, or we did with constructor. We just define some method and add inside some stuff that we want to happen during this phase. So after component was mounted, it just stay on the page until something changes in its data. For example, new props passed to this component, or set state called, for example, if user clicked some button, and either force update function is called. Yeah, so this force update function we don't use most of the time, so if you really need it, it might be called. So it will force a component to update without change of the prop source state. Yeah, change of this three things or firing of these three things will force render to be called, and then some changes will happen in the DOM, and component did update method will be called. So again, here we can do some manipulations with the DOM, run side effects and stuff like that. We can also, stuff like that. And if we want to remove our component from the DOM, everything that will happen in this stage of the life cycle is component will unmount. As you can see here, weak fire, we have did mount and did update, but will unmount. So we would want to do something before unmounting of the component. And before we had much more lifecycle methods. So we had component will unmount, we had component will update, we also had component did unmount, but through the after certain updates, React team decided to get rid of them as they made stuff more complicated and made things unstable. So most of the time, as they noticed, you don't need all of these different lifecycle methods. Only these three are required for you to maintain stable component lifecycle. Yep, so as you can see here, there are a few more lifecycle methods that wasn't featured in this schema. You can find them on the the features on the next slide. So this one are main lifecycle methods. You'll be working with them 90% of the time. If we talk about class components, you're gonna do stuff in them and stuff like that. These lifecycle methods are not that popular. You might work with them sometimes, but not all of the time. So, for example, static get derived state from props. As you can see here and there, should component update, there's a specific one, get snapshot before update. If you want to, you can read after the lecture about them. We won't spend time talking about them, only about this one. We'll talk about only about this one. So this lifecycle method is more specific. So if you remember, I've talked to you, I've told you that when we create class component, we can extend class component from React, or we can instead extend class pure component. And the difference between them in this specific lifecycle method. In component, you don't have it by default. You can add it if you need. But in pure component, this method would be implemented by default, like shallow comparison, stuff like that. What this method does, it defines if components should be re-rendered or not based on the differences between previous state and new props and previous props. For example, in case when your props and state are simple, not deep and stuff like that, this won't make a difference. But if you pass a complex object in props, or you have really deep nesting of the properties in state, this would make a difference for your component's performance. For example, if you pass a new object in the props, but only one property in this complex object was changed, if you don't have this should component update, or you use, for example, you use just component, this update of your component would happen every time. Even if nothing was changed, it would see as this prop as a new object, even if none of this was changed. Nothing inside of it was changed, and that's a problem. So to solve this, you either can use pure component, which have a simple sort of implementation shallow comparison of the props and state in should component update, or you could implement it by yourself. So this component, this lifecycle method returns true or false. True for component to update, and it goes to render and down. If it returns false, it won't update the component, and nothing will happen on the DOM. So that's like that. So that's how you can manipulate changes of your component, more of a re-render of your component and stuff like that. But also be careful with this lifecycle method, because if you're gonna work with some really complex data structure, that's not unlikely, but still you won't want to write really complex algorithm for this thing, because here you can face with a problem when running this method would be more expensive in sort of a performance and time and stuff like that than just re-rendering the component. So most of the time that's not a problem. You just implement stuff in your should component update and you're good. So should component update get for properties inside of it, new props, old props, new state, old state, and you can use it to compare stuff inside it however you like, and based on this comparison return true and false, or true or false, however you like. Yep, and as you can see here, another phase added on this scheme, pre-commit phase, where get snapshot before update. It also can be used for some comparison stuff and getting changes of the DOM and stuff like that. So if you, for example, need to get snapshot of your DOM before it was updated by React, you can do it in here, but yeah, it's not really popular method to use, so let's not spend time on it. So here in this presentation, there is a more detailed description if you want to read about it. We already mostly discussed stuff like that. Here you can find description of the get snapshot before update, stuff that was deprecated. As you can see, methods that I've mentioned, will unmount, will receive props, will update, stuff like that. They are already unsafe. We don't use them. It's just interesting to know for you. So if you'd like to, you can read about get snapshot before update and get derived state from props if you want to. So maybe you have questions here, because that's not an easy thing to understand, and I'd like you to understand it fully, how it works and what it means. So if you have questions, feel free to ask now. Okay, I take it as a no questions and everything is clear. No? Oh, okay. What is actually mean mounting, for example? Mounting, it's like appearing. You can read it as like this. So mounting of the component means that, so if we go from the beginning of from the actual meaning of word mounting, so basically when you sit yourself on a horse, it means that you're mounting. So here you can see it as well. So horse is a page and you is a component. So mounting is you being put on the horse. The component being put on the page. So this is mounting. And unmounting, same thing, but vice versa. did I explain it to you, or I need to give you a different example? Okay, great. So, talking about hooks. So, again, we have class components and we have functional components, and functional components don't have all this fancy stuff with lifecycle methods, and that's not cool because functional components are lighter, let's say like that. They are simpler and don't weigh too much in scope of actual weight, because we in class components we extend components class, so that have already all different stuff that we might not need, where functional components are basically just functions that return JSX, and that's it. So that thought came in the mind of the React developers, and they introduced us with hooks. So it's a new feature of React 16 that allows functional components to have access to all this stuff, lifecycle methods. So let's go here. So there are 3 basic hooks that you would like to work with: use state, use effect, use context. So use effect, use state is used whenever you want to use state of the component, to add state to the component. Use effect is used whenever you want to use component did update, for example. So use effect will be called on every update of the component, props, or state. And use context is for React context, using of the context. We talked about it here when I've been describing you prop drilling. So basically these things when we have access to the certain variables in basically like in the scope. So use context allows us to get access to this feature of the React from functional components. There are much more additional hooks. For example, use callback is used in order to use callback, use memo are used for optimizational things. So when we work with functional components, every time component is rendered, everything that's inside of this function will be called once again. So for example, if we create some properties or some callbacks for our event handlers, these functions will be created once again. So before that, we tried to put everything that didn't need props from the component outside of the component, so it was kind of in a global state of the component, but it wasn't, we couldn't do this every time. Use callback and use memo allows us to memorize these functions and values until something is changed. We also defined what should change in order to these values to be changed, so that's kind of a cool feature. Use ref. We didn't talk about references, I think. Yeah. It gives access to refs, which I'll describe you a bit later. Use layout effect, same thing as use effect, but it's synchronous, and many more. Use reducer, same as effect, but defines same as use state, but defined a bit differently. You can find it more comfortable to use. So yeah, basically stuff like that. When we work with hooks, let me maybe show you. So when we work with hooks, there are certain rules that we want to React hooks when we want to define. So basically, when we work with hooks, we cannot you call these hooks in, for example, if statement or in a cycle, because they because of this its implementation. That's how they were defined, and that's how we have to use them. Yeah, here. So, for example, if I want to use useState, I would do it like this. So I'm calling useState function, pass an initial state of my property that I want to pass. This is the name of the property I want to use. This is a function that's used to reset this property. Here, we usually store simple values, for example, number, string, stuff like that. This won't be a state as it was in a in a class component. If you want to do it as it was in functional component, you would have to use reducer. But most of the time, we just need 1, 2, 3 properties in our state of the component, and that would be enough. So that's why we would work with only one property here. As you can see here, they just created counter, some sort of counter, changing it with a set count on click of some button. Here here they provide a new value for this property in the state and stuff like that. And about use effect, this is an interesting one because it's a bit different. So let me this example. So in use effect, we provide two properties, function, callback function, and an array of dependencies. Everything that we do in the callback function will be fired every time anything from the array of dependencies changes. For example, if this property changed, this will be fired again. If it didn't change, it won't. Additionally, everything that's here will be fired on the mounting. Here, from the callback function of useEffect, we return another function, and this is a function that would be fired on unmounting of the component. So here, basically, useEffect would be called on component did mount, component did update if something from its array of dependencies has been changed, and a function that was returned from useEffect callback will be fired on the component run mount. This is a place where we unsubscribe from some handlers, stuff like that. A good place to do that. Same as with the component run mount. Oops. Yep, so if you want to, as I mentioned before, we cannot call useEffect any hooks basically in if statement or in cycle, but if you need it most of the time, you can do that firing, putting your cycle or if statement inside useEffect. If not, if this doesn't work, you would need to put your component in cycle or if state. Yeah, that's basically it. Use callback and use memo. They look same as use effect, but they don't need to return anything from the callback function. Here, as you can see, and created some memorized callback. I do some stuff. Basically, everything that is here would be memorized, and if A or B property changes, this would be recreated and new function will be passed here. Same with use memo, but we return some value. Yep. Yeah, this is a few links for you if you want to understand hooks and have some practice using them. Nice links to check. When we work with React, we never touch real DOM directly. We always do that. We change stuff in the UI by changing data, though there are a few cases when we cannot do this through data. We definitely need to touch real DOM, and this is where references will come in hand. So yeah, there are a few cases when we need work with real DOM. It's managing focus, for example, if you want to implement certain accessibility feature, for example, when we need to select some text or media feedback or playback, when we need to trigger some imperative animations. So basically work with anything that's connected to animations, like 60% of the time require from you working with real DOM, unfortunately. And sometimes if you need to integrate with some third-party DOM libraries, you also would need to work with real DOM. So this is an example of how you can use references. So basically in the constructor or just in the component, we don't need this. Please remember, in the state, we create some property, and we use create references function from React for that. Then we add this state property in the special attribute of the component ref. Now, from this point, these two things are linked. So basically everything that happened in the custom text input component in the real DOM would be represented in this property. So from this point, you can work with this as a same as you work with element that is returned from get element by ID. So you can have access to focus text input, to the tags and stuff like that. Bear in mind that this part is still not an element, but you have to do .current to get access to all DOM APIs that you want to work with. Yeah, so this references give us access to the real DOM nodes, and React automatically destroys reference since element was destroyed on the page in real DOM. Yeah, we don't usually use references in functional components because they don't have instances. But now with hooks, we can do this with use references. So there's we can cross out that. They allow us to get the child components inside references, and we also can be called method also can be called but not recommended. So yeah, this is basically how we can work directly with DOM. Again, just a few cases where we can do that, and most of the time try to stick to the declarative programming, let's say like this, not imperative. Don't touch real DOM if it's not absolutely necessary. Fragments, we touched them a little bit before when we've been talking about right in the beginning, so let's just refresh our memory about them. So basically when we create React elements, it should be a one node, yeah, and it's not always the case with our composition. For example, I want to create a list of elements or put there just a few of elements, and I want to put this list or two elements anywhere I want. It is reusable, but it can have different containers, let's say like that. I don't want to create multiple divs and put it inside of another div and then in another div. That's why we have fragments here. Yeah, maybe I can find an example. So basically this will help us to avoid div hell. Not this. You? No. No, okay. Never mind. So basically this is a wrapper. So I must create fragment in document in DOM API. This is a shadow component. It won't appear in the real DOM, but it's just a nice wrapper for React not to swear on us that we use double component list of components and not one as a node of component. Yeah, error boundaries. So inevitably, when we create React components or just work with React, we will stumble on some errors inside of React itself, inside of creating JSX, inside of some live hooks, live methods and stuff like that. So that's why we've been introduced with error boundary, and this is a really nice thing to hide broken UI behind. So imagine something went wrong with your properties, or you've been doing some calculation inside your component, and something went wrong. Error happened, so your component basically will be broken. Something like this might help you obviously in dev mode, might help you to define what's going on, what was the problem, and how we can do that with this. So in the past, JavaScript errors inside components used to corrupt React internal state and cause it to emit critical errors on the next renders. React didn't provide any way to handle them gracefully in components and couldn't recover from them. So that's how it had been looking like before. When we've been introduced with error boundaries, we finally had chance to catch our JavaScript anywhere and somehow deal with them, log these errors, and display fallback UI instead of the corrupted UI and crashed and stuff like that. So this is a nice example, but imagine everything in your UI just crashed, and for a user, it's not really a good experience. So they might not understand how to behave in this way, and that might lead to some vulnerabilities in your application. So you don't want to give access to users and potential masters to use your corrupted website. So error boundaries was a good solution. So error boundary is a basic component, same as any class component you might create, but and you wrap with it any component that might be might end in error, or any component that you want to prevent from being corrupted and stuff like that, from displaying corrupted. But it's different from any other component because it have special live hooks. Component did catch and or static get derived state from error. Most of the time we use component did catch. So here are a few examples of where we don't want to use boundaries because they basically won't work. So if error happened inside event handler or in synchronous code, for example, when we do some request or if we set some timeout, and we do some request, some animation with request animation frame, we're doing some server-side rendering. We'll discuss it a bit later. And if the error was fired by error boundary itself, so something went wrong inside error boundary, it wasn't rubbed inside another error boundary. In these cases, our error boundary won't show our fallback on our UI. So to implement some basic error boundary, this is how you can do that. So as you can see, we extending from basic React component. creating some state, if it has error or not. By default, it doesn't have any error. Create some static lifecycle methods. It always return true. So it updates states to the next render will show the fallback UI. And we implement component did catch, very important thing where we can log some errors, do stuff that we want to do. And yeah. No, that's not a good example, sorry. Give me just a second. Let's look for a better boundary because that's not it. Sorry for that. Let's go with something from here. Mm. Okay, let's sorry for that. So yeah, basically our boundary help us to handle errors. Most of the time we use them to for two purposes: to log our errors, so we can after that do some simple stuff with that. For example, look at logs, see that something was crashed, and fire a bug and fix it and stuff like that. So yeah, and for the second purpose, to block our corrupted UI from the users, because we cannot predict how exactly this was corrupted and what happened. So this vulnerabilities of your website might be used to I don't know, get some data from your users. For example, if some input wasn't implemented or wasn't shown correctly, and stuff like that. Okay, so here, implementing the simple error boundary. So as you can see here, I don't need to use any constructor anymore. I just create state which has error false. I implemented simple component did catch where I set in state. So you see the problem here is that there is nothing that changes state, but it's somehow dependent on that. So that's not a good example. So here, when component did catch lifecycle method has been fired, we change our state to true. We put here some error name from error that we get from our lifecycle method and do other stuff. So these things are just for sake of showing something in our UI. So the most important thing is here to change our state of error boundary to false to true. That some error happened when component did catch lifecycle method has been called. So here how render will look like. So basically, if error happened, we want to show our fallback component. If nothing happened, we just show children, everything like that. So I don't remember if I showed you what prop children is, but basically everything that you put inside of your component like that. So this is a parent component, this is a child component. Every time you put your child component like that, you can access it with from props. This dot props dot children. This is where your component will be inside of this error boundary parent component. So this is useful if you want to do complex UI and for purpose of not using extending and inheritance, but using composition in React. You can do that. That looks native, and that's how you do that. So yeah. Yep, so this is basic example of error boundary. So if you want to look on the component that I show, this is a bit complex, though, yeah, I'm telling the user that some error happened. I show the error name and stuff like that. For production, I probably show only this thing, so some error occurred. For development purposes, this is all of this show the developer that what error has happened and where to look for it. Yep. Maybe you have some questions so far. Maybe something wasn't clear. Okay, let's go further then. Header components. This is another nice option for us to make composition of our components a bit more complex. And basically, header component, if you know from functional programming, header functions, it's the same thing. So header component, get component, and return component. But in the meantime, it adds some new functionality, some new wrappers, some UI styling, side effects, stuff like that. So this is useful when you want to add some sort of functionality to different, completely not related components. For example, maybe some authorization, some props manipulation, some I don't know, some styling. For example, I don't know, you want to add border to a certain component and you create header component that would add this border, or complex animation also can be added with a header component. So yeah, main thing that header component does is get some component and return it. So this is an example of such thing. So as you can see here, we get our wrap component in the props. Probably this would be not like that, but yeah, this is a function. Bear this in mind that header component is a function, even though it's called component. So we would use that inside of a component itself before we return it. So for example, here, I created some component and I want it to work only if user is authorized, yeah? So this authorization functionality isn't, so here obviously I use app, but imagine it's some, I don't know, button or form. So I want this certain component to work with authorization functionality, but it's not specific for this component. This authorization functionality can be anywhere in the application, and it can be added to any component. So this is a nice place where I would use my header component like this. So now I created my app component here and I added some functionality to it. Simple as that. So now every time I would use this app component, it always would go with some authorization needed. So it might be some checks for I don't know, existing of the password, or some cookie that defines that this user has been logged in and stuff like that. So here I created some function that gets component as an attribute. It creates new component and basically adds new property here. Just a simple header component that adds a new title, and every time I wrap any component in this header component, this is a new title will be passed. I don't know why would I need that, though maybe, probably. More often we would have some more complex functionality, maybe some component did mount hooks or methods that would, I don't know, get some data, get list, and this is an asynchronous method. So get list, and I pass it in some set state, probably. Const data, and I pass it in state and stuff like that. And then I pass it here as a, let's do it like this. Data. This dot state data, and here data. So here, as you can see, I created header component that would get some data from backend probably, and add this as a property to my component. And maybe I need to get this data in a few places, and there is no point of doing this in every single component where I need that. Of course, most of the time, this certain example, I would do this request in a parent component, yeah, and just save it in context or in some more complex thing like Redux, and access this in the parent components, in child components. Though let's imagine that this is different pages, for example, and components where I want this data to be are not related. Are not related completely, or I don't have Redux for that purpose, or stuff like that. So this is very specific example, just for the sake of telling. Most of the time we would obviously implement this a bit differently, but yeah, probably there is a case where I want to do that. This happened, or maybe this is get list doesn't go to directly to the backend. Maybe I go to the Redux state or to the context of my application. This is probably might happen more certainly might sorry, words are hard. This is more probably will happen in this case. So we kind of get some data, pass it here and stuff like that. Very simple example though, again, might happen. So maybe you have a question on this stage. Want me example, or want me explain a bit more about stuff like that? Is it something similar to decorator? Yeah, this is basically a decorator. So yeah. Okay, let's maybe have a 3 minutes pause in this time or not. We're almost finished with the, yeah, let's do a pause here and for 3 minutes, and we'll return back and talk about forms. I need just a little breather. Okay, are you guys here? Only Ilya is here? Yeah. Okay, great. At least 3 of us are here. Okay. So, oh, 4, great. So the last topic for today is forms. And this might be a bit complicated because it have to be implemented very specific way. So let's discuss this a bit. When we create components in React, we usually have only one-way data binding between child and parent. So one-way data binding is unidirectional, so we can pass and change data in parent and it will be reflected in a child, but if we do the same thing in the child, it won't reflect parent. Obviously, the trick when we pass some binded function from parent to the child and call it in the child is still a unidirectional binding. It's just a hack that we use. So basically, we just change some data directly in the parent from the child. We do not change anything in the child itself. So like that. Two-way data binding help users to exchange data from the component to view and from view to the component. It will help user to establish communication doubly directional, bidirectionally. One way is unidirectional. You can only bind the data from component to the view or from view to the component. This is more of a, let's say, on a step higher explanation. So basically when we if we talk about the application as a whole, so we have data. Okay. All React is built with a certain pattern in mind. It's MVP, model view, MVC, sorry, model view controller. So view is our UI, model is our data that we change, and controller everything that we do inside of our application. So here, in this example, two-way and one-way binding is when we two-way when we change data and it reflects in view. It's our basic components that we work with. Two-way binding here, if we not talk about component directly, about the structure of the application itself, two-way data binding would change data when we change UI, and this is exactly what we do when we work with forms. We pass some data in our input, and we change our data inside our component. This probably might fire changes in UI again. But yeah, bear in mind that if someone would talk about two-way data binding in scope of the component, we don't have this in React. Yeah, in order to implement some sort of input in React, we have two ways to do that: controlled and uncontrolled component. Controlled means React has control over data that would be shown on the UI. Here in the example, you can see how it's implemented. So we have some sort of component with value inside of state. This value is used in input as a value. So basically, now we're binded. If user at this point without this things, yeah, if we just do this and add value in value of the input, user won't be able to type anything because we kind of controlling the value. basically React at this point controlling the value of the input, not UI, not real DOM, React. How can we allow user to type something? We add handler. So every time user types something, change event happened, and on change we would fire our custom handler that would get value from target, from our input, from event object, and put it in value of our in value property of our state. So every time user type one symbol or remove some symbol or do anything inside our input, this handler will be fired and it will change our state, and this would be reflected in UI. This is basically some kind of a loop. This is what I've been talking about when we've been talking about this with loops. So basically we input something, we change, say when input something, when change happened, set state fires, write some data into our value changed, so render would happen because every time state changes, our component re-renders. This will re-render with a new value inside of a attribute of an input. Basically, this is how control component would work. This is how 90% of components of components inside forms would be implemented. Most of the time we want React to have control over our if I want to submit this form, bear in mind that prevent default is not obligatory if you want to. This was written just in order to not submit anything. But same thing will happen. And if we want, if there is a reason, then when we need to DOM to control over our component values, we would use references. So basically, when we've been talking about refs, one reason why we would need this is a text selection, and this is exactly where we what has been meant behind this. So we create reference. Where is it? Not here. So in our state, we created input, created references. We put this in a ref property of our input. So now they are binded, and every time we again here we already don't need to do on change. We basically give DOM control over change of this thing. So here only when we submit the form, we want to read data from this input and do something about it. Maybe put it in certain data structure or send it as some request and stuff like that. Yep. So yeah, it looks like control component are in scope of code they're smaller, but again we don't want to in React most of the time we don't want to work with real DOM. It goes against deterministic philosophy of the React. First of all, and yeah, stuff like that. The case where we might need that is hard to remember. I don't have it on top of my head, unfortunately, but yeah, just because most of the time we would work with control component, but again, know this. Yep. Yep. This is how we can implement our custom forms, but there are a few nice libraries that you might consider using in order to handle your forms better. Obviously, again, in your application, it's hardly needed, just for sake of practice, you might want that. Give me just a second, please. Okay. So one of these libraries is Formic. This is one of the most popular. We use this in production a lot of the times. It's free. Most of the time it's easier to understand, but yeah, but it is cool. Again, but sorry. Again, in your application, I would recommend starting with control component and your custom form, and only then go to some library, just to have more experience in different sort of approaches of that. So yeah, Formic has a lot of things created under the hood. So as you can see here, you don't need to have any state and stuff like that. You just created using Formic component, provide some initial values, provide some functions for validation, handling submit comes with Formic again. As you can see here, so in Formic, I don't really provide a component itself, but a render function. This syntax is here. When we provide not component, but a function inside our component is called render function. And it can be used for sake of providing some properties inside of a child from a parent. Yeah, so as you can see here, handle submit, handle blur, change comes from Formic itself. You just pass it here, simple, cool, and all of that. The nice thing about Formic that it can provide you validation functionality that if you've been writing this on your own might be a bit code time consuming, let's say like this, not really complicated, but a lot of things need to be written for that. Yeah, if you have Redux in your application, you also might consider using Redux form library. It is a high order component that uses React Redux to keep form state in Redux store. Also a really nice thing, as usually when we work with forms, we submit or get or send some sort of data, something changes. For example, if we're in store, some sort of a shop, we buy something and we want user to put address, shipping address. And obviously after user submit this data, we want to put this in our application store or application state, how we like to call it. This is a nice thing to use in order to automate it a bit more. Yeah, let's not go in depth because we didn't touch Redux yet. Yeah, another library, React Final Form. It's built by the same authors as Redux Form, this one. React community moved away from React Form in search of more lightweight and performant alternative. That's why React Final Form has been written, and yeah, it doesn't have any dependencies in order to do that. Here, as you can see here, we import form and field from React Form. This is how these libraries most of the time would work. See, again, with Formic, we did the same thing. We have wrapper, we do some on submit. Here it's this function is a pure function, doesn't have any side effects. That's why we put it outside. We can provide again some initial values. We can do something in render, and here again we're passing not component but a render function. Simple as that. Very yeah, looks like looks like Formic, but Formic more popular just because it gives us more possibilities. So I definitely would recommend, if you would want to use any library, start with Formic. Yep, and this is pretty much it for today's lecture. And we ramped up with React, all stuff. So next lecture we will start with Redux. Probably gonna spend 2 more lectures with this, and the last lecture I probably will cover testing or do some live coding. We'll see how it goes. So let's go with the questions about the lecture and move to your home task. Do you have any questions about topics that we covered? Maybe any topic that we already covered in React. Maybe you read already something and have some questions to me. I'm happy to explain to you stuff. Okay. Two-way controlled forms. It's basically controlled component. It's just how we with it. So this is just example. So basically one way data binding, like say it's about uncontrolled component one way. So we don't have data value in the state of our component, where in two-way data we kind of have it. And what is the use case of two-way controlled forms? Basically, any form would be two ways controlled. Wait, no, sorry. Yeah, basically any form would be two ways controlled. So you kind of type in something in UI and it changes data. Yeah, this is one way. We typed something and it changed data. This is how uncontrolled component would work. If we talk about two-way data, we type something inside, UI changes basically, but this UI change data. This data change UI in as an answer to this change. So basically here on change on the fire of this event, when user types something, this handle will happen, and this would change state of our component one way. But when we change state of our component, it fire re-render of our component, so it will be reflected in the UI as we change value of our input. So this is kind of data comes here, changes this data, input come here, changes this data, change of this data, change UI. So this kind of two ways. So any implementation of the function of the form or input would be two ways binding. We can also, for example, change state of our component not only on change, or maybe we would want to change it on on some other event. For example, we do request. No, let's do like this. Every time you probably notice that sometimes when you fill up the form, you reload the page, data is there already. Yeah. When you change stuff inside the input directly, this is one case. But when we load the page, probably some data would be fetched from the backend, and it will change state of our component. Our form component, it would add new values, and this data would change. This is again one way, because we just changed the data of our component, and this in response changed the UI. Again, one more example of that. Okay. If no questions, let's quickly move to your home task. Again, if you have more questions while we talk about your home task, feel free to write them in the chat. So your home task will be to create a news app. And yeah, here's the prerequisites. Now it's interesting. So description. In this task, you're going to create a news app. This application should use OpenAPI News API. So basically, you will get all your data from this new News API. It's completely open. You don't need any subscription and stuff like that. Only thing you need is an API key. To get this, you just need to sign up to this website. Nothing to pay, nothing to do, just sign up and you'll get your key. Yeah, basically when you click here, you'll be redirected to the page where you will be provided with key. You put it here instead of this thing, and you'll be ready to go. So keep that in mind. Pay attention to that. Don't forget. Yep. So there are a number of features that we want you to implement during this task. First of all, your application would have 3 pages. Homepage, where the list of new articles would be listed, 20 of them. They should go from newest to oldest. If I go to /ID of my article, I should be presented with the article page. And yeah, and page 404. This page should tell the user that page that they're trying to visit doesn't exist, to show 404 status and some description that, hey, this page doesn't exist, stuff like that. So list of news should be in a certain, let's say, format. So it should have picture, title, source. Source is basically an author, journal, I don't know, so like BBC, CNN, stuff like that. Date of publication, description of the article, short one, not long one, so not the whole text of an article, just a short description, and link for us to read more. So basically when user will click on this read more link, he should go to this URL to read more about this. All this data will come again from your news API. So here, as you can see, the source, you can have a name of the source. Maybe if you want, you can add author, the title of the news, description. This is a short description of the article, URL to image, published date of publication, and content. Yeah, if no picture was returned from the API, some placeholder should be displayed instead. So there are a few requests that don't have URL to image property, so you have to create some sort of fallback for that situation. Use any placeholder you like. Yeah, clicking on the link, read more in the article preview. User goes to its page and can read full article. It should have picture. The page of the article should have picture of the article, source of the article, full article text. Basically what you have here. Yeah, it doesn't have like a full text it used to, but never mind, just put it there, don't worry. Date of publication and link to return back to the home page. User should be able to filter news by source, so basically change different source of news. I would recommend you doing this by creating some sort of a drop-down where the list of different sources would be listed, and user just clicking changes the source of the news. As the sources are, as there are a lot of sources, basically like maybe hundreds, you might want to create additionally some search bar inside this dropdown, though this is not this is optional. That's like a start task. You don't have to do that, but if you want to, feel free. Users should be able to search for a specific article in the selected source. So basically, I'm as a user selected some source from a drop down, and I should also have access to some search bar, like this, basically, and be able to search by title in this specific source to find the specific article that I want to see. So I write some title, I click search. Let me open an example. I type here some title, I click search, and it should list me different articles inside of certain source. Here it's BuzzFeed. Yeah, so while articles are loading, it might take some time, like a second or maybe like half a second. Spinner should be displayed. So basically it shows to user that some response, that something is happening. This would happen when you change source, for example, when you first time load the page, when you search by title, probably. So yeah, some kind of a response for user that his change has been registered. His call for action has been registered. If there are no articles that match request, a according message should be shown. So basically, instead of list of articles like here, you would have something like that. There is no articles matching your request. Yeah, so maybe the title was written wrong, or certain sources doesn't have articles now for last like few days, for example, because when you fetch only 20 of them, you're basically fetching like newest, maybe, because yeah, basically I faced the situation when sources didn't return any articles, so you need to be prepared for that too. And the optional task, if you have time, when user scrolls down and reaches the last article that was loaded, so the first time it would be 20th article, new chunk of articles should be loaded and added to the end of the list. It should allow user to load additionally up to 100 articles. So same mechanics, you can see, if I'm not mistaken here. Yeah, so as you can see here, scroll shows us that we have like a double more pictures of a cat here. But if I scroll down, as you can see, it jumps up. So a new chunk of cat pictures has been loaded. If you want to, you can implement the same thing for your application. More often you see this functionality implemented with Pagination. Pagination, when I click on a second, this would reload the page, or maybe add to the list of sources, new sources. Sometimes it's implemented like this. In our case, same thing would happen on user reaching the bottom of the page. So there are a few details that I want to mention, and yep. So page shouldn't reload when user is clicking your news app link. So while user is going through your application links, this thing shouldn't cause page shouldn't be reloaded, basically. So pay attention to that. Make sure that you're using React router links, not a general links, that every time user goes back and forth When user goes back and forth, nothing, pages doesn't reload. We stay on our single page application. At least minimum styling is expected from you to implement, so nothing like Web 2.0, but something decent. Again, we gave you a few examples how this can look like. You don't have to implement same as here. So here you can see that there is some sort of hover state is presented. So when I hover on this card, this overlay, like blackish overlay appeared, and source and date of the publication appears. You don't have to do that. It's just for sake of example of showing how this might look like. You can do however you like. Yeah, page should be responsive and look good on mobile. Minimum possible width 320 pixels. Page shouldn't stretch to the full width on the device. So, for example, you can test it. Yep. You can test it in Chrome like this. So basically we go on to some page. Here it's our GitHub. We inspecting. We click here, and so this is how it should look. We can test how it looks for mobile. Again, some transitional widths also should look fine. And for what is meant in this, when we talk about full width of the page, so if user looks on the page on a very big device, this content shouldn't be stretched to the full width of the device. It should have a maximum width for that matter. Example of the design, yeah, attached here. If some error happened during component render, it should be handled by error boundary. We've talked about it together and should show error details. Use Redux for state management. It is recommended to start your app without it. Maybe use some context or just pass props. And only when all of your components are in place and Redux state management. So I recommend you starting with some state of your app being stored in the highest component in the hierarchy. So basically in your app component or in your page, in the component of your page, in component of the home page, in component of article page, stuff like that. This might be your starting point of handling stuff. And this would make process of moving everything in Redux a bit easier. Please separate different Redux instances in different files. Example will be provided below. We'll return to that when we cover Redux. For now, there is no point of explaining what I mean. It is recommended to use feature approach to maintaining your app folders. Again, example will be provided below in folders, component, and pages. So let's go to the example and see what was meant by that. So this is example of the repository. We go to SRC folders here, components and pages folders are presented. So let's go to components. For example, to do components. So here, as you can see, separately is stored app, header, and to do. Basically, in your application here might be some component or some article component, for example, and some sources drop down, some search input. They also would be stored here. Inside of every all of this component would be its child components, like here. So I have parent component to do. Inside of this, I have component add to do item, and list of to do. So when you read stuff about Redux, you might stumble across approach of storing components and containers separately. Component is, yeah, I didn't cover it, I think. So basically storing smart components and dumb components separately, or stateful and stateless component, also called like that, separately. That's not, that might go wrong really quickly. You basically will be confused really after a few days of implementation of your application. That's not really native and hard to understand through sometimes. So that's why I recommend you to put child components when you're sure that this child component can be used only inside of its parent component. Be free to put it inside of the parent component folder. If you think that this component might be used somewhere else, there are two ways where you would like to put this component. Either directly in components folder, if it represents some feature, again, to-do list, some sources, some specific input, maybe article. This component is very specific and it's unique. You would put it inside of components folder. If it's some very common component, for example, just input, simple input without any binding to its specific functionality, or button, link, I don't know, some typography, for example, P tag with some styling or different headers. These all are very, let's say, common component. They might be basically used anywhere in your app. If you want to separate them, it is recommended to put it here. So basically you'll create another folder called shared or common, wherever you like to write it, and put this component there. That's will allow you to use it in pages and components, different components that represent features and stuff like that. Again, this folder can be called features to be just more direct. Yeah. Yeah, before you start development, please make sure that ESLint is working and has basic rules for React application. So if you choose to create your application with Create React App, it already have some sort of a ESLint setup. You can read here more how to add more rules if you need it. So yeah, please do this. It will simplify work of your work basically, and if someone would check your homework, it would also make it easier for them. Yeah, and also this is one thing that we also do on production, so this would give you some insight of on production like applications. Also add this running of this command, running ESLint command on pre-commit hook using Husky. It's basically a library that allows you to do something before committing or pushing something in the repository. Yep, so here we want to fire check of ESLint before we're committing. So every time you run git commit message blah blah, ESLint would run, and if something fails during ESLint checking your application, it won't let you commit. That's fine. This is absolutely great because it means that it found something that was done not correctly in scope of some syntaxes and stuff like that. You need to fix it and then commit it again. Yeah, if we have time, we'll cover testing in React. And if this happened, you'll be asked to cover 5 component with unit tests and add again running tests on pre-push hook. So again, every time you do pushing in your repository, tests should run and check your components. Again, if tests fail, push would be blocked. Also, we'll cover we'll I'll tell you how to add coverage in your test, so you'll be asked to add it in your application too, and for your 5 component to be covered by testing 100%. So here, please choose more or less complex components, not like dummy component like a button and call it a day. You'll be asked to choose something smart with state, probably some hooks and stuff like that to be sure that you know how to write tests. Additionally, I'll add a few more points here in details to use prop types. If you want to practice formic, please go ahead and use formic for your form. And in scope of routing, I also added here to make sure that when I copy or user copies link to certain page, for example, to article page, and share it with their friend, if this friend goes to this link, it should open certain article, not a home page. So we've talked about it somewhere here. So basically this thing, location-based external state of the page should be implemented. So basically this. Yeah, pay attention to that and make sure you're choosing right right router for that purpose. This, if you do this correctly, it should work from the under the hood, but yeah, just pay attention to that. Yeah, we ran out of time already. Sorry for that. If you do have any questions about your home task, this is nice time to ask them. Okay. If no, we'll have a few more lectures, so you'll have time to ask them again after reading yourself. Okay, that's basically it for today's lecture. Thank you everyone for participating.